Hi and welcome. My name is Abdel. In this video I'm going to introduce you the concept behind OSPF. OSPF is an interior routing protocol, or as well known as link state routing protocol. Updates in OSPF are sent whenever there is a change in the routing topology. Each router sends state of its interface to all routers in the area. In OSPF is fast to converge and use hello protocol to form neighbor relationship between all the routers. OSPF is also classless routing protocol that sends subnet mask along with the update using a multicast address of 224.0.0.5. In OSPF, OSPF requires a hierarchical design, meaning that you need to design the network in areas to reduce link state advertisements which are flooded to all routers inside the area. So to keep a routing table small and reduce the overhead of OSPF, you need to design an OSPF in a hierarchical design in areas. In this video I'm going to walk you through implementation and configuration of OSPF. As you see here in the I have GNS3 and I have 3 routers right here, and I will start them right now and begin the configuration. We'll wait a little bit. GNS is loading and we will go through the configuration of OSPF. We will start with router 1. Smosh CRT window, just we can see the topology. First thing, we need to enter global configuration command in order to configure IP addressing and the rest of configuration. Now I want to configure the IP address on router 1. Let's bring the interfaces. Okay, let's go to serial 0/0, which is connected to router 3, and we'll have the IP address of 10.0.0.1 with subnet mask of /30. Bring the interface up with no shutdown command. Now let's go to serial 0/1 and give it an IP address. Which is 10.0.0.5. I'm using variable lint subnet mask in here. Bring the interface up and verify the configuration. We do show IP interface brief. As you see here, the interfaces are assigned and they are both up and up. You can configure OSPF on interface basis or in global configuration command by issuing router OSPF followed by the autonomous system number. And the autonomous system number in OSPF doesn't need to match in a like a GRP, which need to be matching. So let's give it an OS 100. IP OSPF, router OSPF 100. And we want to advertise OSPF on both interfaces. In this case, we'll use a wildcard mask of 0.0.0.255 and specify the area. In this case, router 1 will be in area 0. To verify routing protocols, issue the command show IP protocols. Here we have an OSPF autonomous system number 100, and we are advertising the 10 network in area 0. This router right now, which is router 1, is sending hello messages to router 2 and router 3. Since the router 2 and router 3 not is configured, they will not form a neighbor relationship. So let's hop to router 2. Just to verify the IP addressing, router is still blank. Let's go to serial 0/0 and give it an IP address .6 in this case, and bring the interface up. On router 2 we want to advertise also the fast Ethernet link, which has the IP address of 172.16.1.1 with a /24 subnet mask. Verify the IP addressing configuration. We need to issue no shutdown on fast Ethernet link. And fast Ethernet has come up. Now we need to issue the command router OSPF and the autonomous system number. As I mentioned before, the autonomous system number in OSPF doesn't need to match, and we are going to advertise those networks. This link, which is in area 0 and 172.16.1.0, wildcard mask of 0.0.0.255 and put it in area 1. Verify OSPF, and sure enough we are advertising the 10 network and 172.16.1.0 network. OSPF is unlike AGRP, doesn't auto summarize by default. So at this point we need to see a neighbor come up. By issuing the neighbor command, I think there is a problem here, since our neighbor hasn't come up. We are actually sending OSPF update on this link, but it seemed to be that where the network command is wrong under OSPF. It's a good command to use. Do show run section OSPF and issue the no command under this configuration seems to be wrong, and reconfigure it again, which is 10 0.0.0.0.0.255 area 0 IP OSPF neighbors. Sure enough, we have formed a neighbor relationship with router 1. Do show IP OSPF interfaces. It's useful command to verify OSPF is running under an interface. We have serial 00, and we're running OSPF in area 0. Process ID is 100, router ID is 172.16.1.1, which is the higher IP address. OSPF uses the higher loopback address as a router ID, and in case there is no loopback, it uses the higher physical IP address on the router. And the router ID, it has a major rule when you are configuring OSPF virtual links. Maybe that's a little bit advanced, maybe for CCNP curriculum. And we are running OSPF on fast Ethernet 0.0 in area 1. Okay, at this point you can verify the routing table. Show IP route. There is no routes advertised because this link is directly connected. Let's go to router 1 and issue the same command, IP route, and I can see here that we're learning 172.16.1.0 through router 2, and 110, which is the administrative distance of OSPF. The administrative distance, by the way, is used when there is a route or a route to a destination that is learned via multiple sources like RIP, AGRP, and OSPF. And the administrative distance, the lower is better or more believable. This means inter-area route, which is learned from area 1, and this router right here is called at this point ASBR, area border router. We want to configure OSPF also on router 3. Smush the window a little bit. Everything is still blank, and let's configure router 3 IP addressing. We have serial 0/0. Let's give it an IP address, which is in this case 10.0.2. and issue no shutdown. And we want to advertise also the fast Ethernet link, which is 192.168.1.1 with /24 subnet mask, and bring the interface up. The interfaces are assigned IP addressing, and both of them are up and up. Now let's configure OSPF 100. We want to advertise the fast Ethernet link, and as I mentioned before, you can run OSPF under an interface basis by going to the interface and configure OSPF under the interface. For example, we can do it now. 00/0 and IP OSPF 100 area 2. Show IP OSPF neighbors. Other OSPF 100. You can also configure router ID manually by issuing the command under router configuration command router ID and give it an IP address, which is a 16-bit IP address. Verify the configuration, and this command is useful to see the process, which is 100, and neighbor ID, which is 3.3.3 in this case. Let's see if we have formed neighbor relationship. Both interfaces are up, and let's verify 000 IP address, which is /30. Let's do a ping to router 1, 0.1. Sure enough, we can ping it. Yes, 000 interface, and run OSPF and area 0. That's the problem. We can see that neighbor has come up from loading to full. OSPF has a process which starts with initial, then loading to full neighbor relationship. At this point we can see OSPF neighbors by issuing the command show IP OSPF neighbors, and sure enough we have formed neighbor relationship with router 1, which has the router ID of 10.0.0.5, and that's, by the way, is the highest physical IP address on the router 1, because we don't have any loopback interfaces configured. So let's issue the command IP OSPF interfaces, I meant interfaces, and we are running OSPF under fast Ethernet 00 and under serial 00. Now let's verify the configuration on router 1, for example. Do show IP route, and we have learned 172 and we have learned 192.168.1.0 from area 2. This is inter-area route, the route between areas. The O right here, which is OSPF, in the same area. If we have another router connected to this router in the same area, we will see the O without IA next to it, which is inter-area route. To show IP OSPF database, we have link ID and we have the advertised router. This is router link states in area 0. Router link states are routes in the same area and are sent by DR or designated router. Summary link states are advertised by ISBRs like router 2, which is an ISBR, and router 3, which is also an ISBR. I want also to add some IP addressing on router 3 and show you how to summarize routes in OSPF. Let's go to router 3. Let's add a loopback 0, for example, and give it an IP address of 192.168.2.1. Loopback 1 IP address 3.1. Okay. Under loopback interface, you don't need to issue no shutdown command. Like under the physical interface, you need to bring the interface up because loopbacks are always up, at least if there is a one physical link up. Verify the IP address in on loopbacks, and sure enough we have 192.168.1.1.2.1 and 3.1. And summarization, you can summarize in OSPF just on ASBRs. And to summarize, you need to enter router configuration command, this case router OSPF 100, and issue the command area, this case area 2, and range, followed by the range command and the IP address that you want to summarize. We have 192.168.1.1.2.1 and 3.1. Okay, so our summary address will be 192.168.0.0.0.0.3, because we are concerned about .3.255, because we are concerned about the third octet. Okay, concerned about the third octet, and we have Intel here, we have a /16. Okay, by adding a 6 bits, which is /22, which is 255.255.252. I'm mixing this stuff because I'm using wildcard mask here, but instead I need to, and here we go. On router 1, in this case, we'll verify our summary route, and sure enough, we have summarized route to area 0. To verify on router 2 as well. To to be more specific, issue the command do show IP route OSPF, so it shows just the routes learned via OSPF. And our summary route, which is an inter-area route coming from area 2, has summarized to area 1. At this point, all routers are configured, and I hope that this have been informative for you, and thank you very much.